Assalamualaikum. My name is Muhammad Azharul bin Razilan. I from RY40. My matric number is 1913820069. Okay, today I want to present my PGT213 analog electronic circuit 2. The first one is the to illustrate what an OM is. We need to consider its ideal characteristic. Okay, the first one explain what's an ideal OM. This is the first component for OM. Okay, OM stand for operational amplifier. Is because they were used to the model the basic mathematical operational of addition, subtraction, integration, and another else. In this science, a true operational amplifier is an ideal circuit element. OM may be a package as a component or used as element of more complex integrated circuit. Operational amplifier. The ideal OM is an amplifier which infinity input dependent, which is does not load the driving source. Infinity load infinity open load gain, zero open dependent drive any load. Infinity bash which is a flat magnitude response and zero input offset voltage. It have positive and negative input which allow circuit that use feedback to achieve a wide range of function. This is a there is have a two golden rule. Is a The first one, in a closed loop, the output attached to do whatever is necessary to make the voltage different between the input zero. The second one is the input draw no current. Okay, the next question is distinguish the property of a LM741 to those of an ideal OM. Oh, this is a figure of LM7.741, and this is a ideal OM. Okay, from the data sheet of LM7.741 is larger signal voltage gain is 200 volt per millivolt. It means a open loop gain of 100,000 if you operate an OM in open loop condition without negative feedback. Even microvolt of input voltage will drive the output to centrigation. Almost of the amplifier circuit OM is a configure to use negative feedback, which is reduce the voltage gain. Its output will be always at saturation, positive or negative saturation. In an integrator circuit, the DC gain should be limited by adding add, adding a feedback resistor in parallel with a capacitor, else the output will be get saturate. Or for ideal OM, F infinity gain, zero input current, zero offset voltage, and zero phase shift. It also have a it also have a infinity frequency response, and no transist issue. Practical OM do not have any of those. The second question is, if the OM were perfect, the ideal step response of a OM will be produced. In practical, however, the output is the exponential with a certain time interval. Okay, the question is, show a OM with a input voltage step and is resulting output voltage step relating the slew rate. The slew rate of a OM or any amplifier circuit is the rate to change in a output voltage cause a step change on input, as you can see the figure here, where input voltage at the zero here, input voltage in zero, automatically the output will be detect the zero, and the wave will be have a curve as a cross up level until the input voltage become a zero back here. So the output voltage will down intense. It's because a major change in a given time. Okay, the next question is, explain what is slow rate. Is it important? And defend your answer. Okay, slow rate help us identify the maximum input frequency and amplitude applicable to the amplifier such the output is no significantly distortion. True, it's become imperative to check the datasheet for the device slow rate become before use it for high frequency. Okay, the third question is, given an explain of a n inverting amplifier using n OM with a component value and explain it. This is my circuit I construct with I construct using RT-SIM live. Okay, the first question is, where is the virtual ground is? Here on a circuit I already mark it. Okay, in a OM the term virtual ground mean that the voltage at the particular node is almost equal to the ground voltage at a 0 volt. Is not physically connect to the ground. This concept is very useful in analyze of OM circuit, and it will be make a lot of calculation. It's very simple. Okay, the second one. The second one is, as you can see, the negative voltage cause the input resistance is equal to V in. Here, here is a cross of is cross a resistance value which is R in. So R in go to the V in because the resistance to the ground here. Okay, the next question. The closed loop voltage gain and input independent. Okay, here the formula V out per V in equal to negative RF per R in. Don't forget the negative, right? Okay. Firstly, you need to know where is the R, RF and R in. Here, here is R in and here is RF. So we need to multiply. So 1 kilo ohm over 10 kilo ohm. So you get a 0.1 ohm. So input dependent is Z in equal to R in. Easy. Okay, the next question. Okay, the last question is construct a summing amplifier and summarize the theory of operational. Okay, this is my design. I use a Martin live. Okay, so here is the formula we need to use to get the calculation. Okay, firstly we need to learn the about a summing amplifier. It's a configuration. It have two type of amplifier. Summing amplifier is have inverting and non-inverting, and it have a few application of summing amplifier. One of the important application of a N op OM is the summing amplifier, and another known as a adder. As the name suggests, a summing amplifier is an OM based circuit which multiple input circuit of a different voltage are added. Okay, for information on the base of OM, the most commonly used summing amplifier is an S10 version of the inverting amplifier configuration. Configuration multiple input are applied to the inverting in terminal of a OM, whilst the non-inverting input terminal is connected to the ground. Due to this configuration, the output of the voltage adder circuit is out of the surface by 118 degrees with respect to the input. Let R1 be the input dependent and V1 be the input voltage of the first channel. Similar R2 minus V2 for a second channel. R3 minus a V3 for a third channel, and so on up to Rn minus Vn for the another channel. It's a really been said that a summing amplifier is basically an inverting amplifier is with a more than one voltage at the inverting input terminal. The output voltage for each channel can be calculated individually, and the final output voltage will be the sum of the individual output. If V in is the combination of all the input signal, then this is apply the non-inverting in terminal of the OM. From the above circuit, we can calculate the output voltage of the non-inverting amplifier with a V in as input and RF and RI as a feedback divider, resisted as follow. So the formula is V out equal to V in 1 plus RF per R in. As the output voltage is figured out, we have to determine the determine the value of V in. If V1, V2, and V3 are the three main input source, and R1 and R1, R2, and R3 are their input resistance. Then V in V V in 1, V in 2, and V in 3 are the input of the respective channel when another responding channel are grounded. So V in equal to V in 1 plus V in 2 plus V in 3. Non-inverting summary amplifier can also be construct use the non-inverting amplifier configuration of the OM. Here, the input voltage are applied to the non-inverting input terminal of the OM, and the part of the output is the feedback to the inverting input terminal through a voltage dividend bias feedback. Okay, that's all for me. Thank you, sir.